Manusia sudah bertahan di bumi ini selama ratusan ribu tahun, menghadapi berbagai macam tantangan dan bencana. Dalam setiap tantangan, manusia selalu beradaptasi, bertahan, bersiteguh, selalu berusaha mencari solusi yang terbaik.
Dengan transformasi digital, kita sambut revolusi industri keempat.
Disrupsi selalu terjadi setiap zaman. Saat ini, kita memasuki era revolusi industri keempat dengan open source sebagai kunci perubahan. Kita sambut era baru dengan penuh semangat. Menggunakan open source dengan baik, memerdekakan kita dari ketergantungan vendor login. Kita sambut era baru dengan penuh semangat. Menggunakan open source dengan baik, memerdekakan kita dari ketergantungan. Dengan semangat kemandirian, kita lakukan research dan implementasi open source demi mencapai kedaulatan yang seutuhnya, membebaskan diri dari ketergantungan teknologi asing. Equnix mendedikasikan dirinya untuk menjadi perusahaan solusi IT terdepan dengan keunggulan research dan open source. Equnix selalu memberikan solusi yang terbaik dan menyeluruh untuk enterprise. Mendedikasikan dirinya untuk menjadi perusahaan solusi IT terdepan, mewujudkan nilai-nilai kemandirian, kemerdekaan, dan kedaulatan. Dan menyeluruh untuk enterprise. Mewujudkan nilai-nilai
bersama-sama video company profile dari Equnix Business Solutions. Di situ terlihat ya bagaimana kita berdiri, kemudian visi misi kita, serta solusi apa yang kita berikan. Nah, sebelum kita masuk ke acaranya, mari kita menyanyikan lagu Indonesia Raya bersama-sama. Untuk rekan-rekan dimohon untuk berdiri. Video company profile dari Equnix Business Solutions. Di situ terlihat ya bagaimana kita berdiri, kemudian visi misi kita, serta solusi apa yang kita berikan. Nah, sebelum kita masuk ke acaranya, mari kita menyanyikan lagu Indonesia Raya bersama-sama. Mohon untuk duduk kembali. Oke, baik rekan-rekan semua. Nah, kita sudah masuk di acara kita tunggu-tunggu pada pagi hari ini. Sekali lagi saya ucapkan selamat datang di acara Meet and Greet with Alexander Kukushkin yang bertemakan Patroni Cooking Guide. Tepuk tangan ya rekan-rekan semua. Oke, baik rekan-rekan semua. Nah, kita sudah masuk di acara kita tunggu-tunggu. Nah, sebelumnya mungkin saya belum memperkenalkan diri nih rekan-rekan. Kenal kata saya. Perkenalkan nama saya Neva. Dan di sini saya selaku MC yang akan memandu jalannya acara pada pagi hari ini. Nah, untuk itu kita juga akan memulai acara ini yang bertemakan Patroni Cooking Guide. Oke, I would like to welcome and thank you Mr. Alex for become speaker of today's event. Nah, untuk selanjutnya kita akan memperkenalkan rekan-rekan semua moderator yang akan memandu jalannya diskusi pada pagi hari ini, Bapak Luki Haryadi. Boleh tepuk tangannya untuk Bapak Luki Haryadi, rekan-rekan semua. Ya. Oke, jadi Pak Luki ini selaku Chief Technology Officer dari Equnix Solutions ya, Pak ya. Memandu jalannya betul, Pak Luki ini telah memulai karirnya nih rekan-rekan semua dari 2010, yaitu sebagai providing atau memberikan solusi open source nih untuk masyarakat ya, Pak Luki ya, betul ya. Dan juga setelah memulai karirnya sebagai programmer dengan beberapa bahasa-bahasa programmer yang dikuasai gitu ya, rekan-rekan semua. Nah, oke, untuk selanjutnya tanpa berlama-lama lagi rekan-rekan semua, mari kita persilakan Pak Luki source nih untuk jalannya diskusi dengan Mr. Alex pada pagi hari ini. Untuk Pak Luki, waktu dan layar dipersilakan. Mulai karirnya sebagai programmer dengan beberapa bahasa-bahasa programmer yang dikuasai gitu ya, rekan-rekan semua. Nah, oke, untuk selanjutnya.
Okay, good morning everyone here as offline audience and also online audience. How are you? I hope you all fine well. And then today also we have a special events, yeah. So we have a meet and greet with Mr. Alexander Kukushkin as the Patroni guy, as you already know, yeah. So before we started, how many of you already use Patroni? Can you raise your hand, perhaps online and also offline? Yeah, 1, 2, 3, 4, also many, yeah. So you have very big fans, yeah, using Patroni. And then before we get started, I will introduce you also about our speakers today, Mr. Alexander Kukushkin. So as you already know, Mr. Alex is the founder. Okay, and perhaps Mr. Alex, you can come to the stage, please. Yes. And then before we get started, okay, you can say hello to everyone in here.
Morning.
Morning, yeah. Mr. Alex today is specially come to Equnix to give some explanations about the Patroni Cooking Guide, and Mr. Alex here also as the biography. Perhaps I will introduce you a little bit. Mr. Alex today is specially come to Equnix to give some explanations about the Patroni Cooking Guide, and Mr. Alex here also as the biography. Perhaps so many speakers from outside Indonesia, and Mr. Alex also the one of the speaker. And today also we will talk more about Patroni Cooking Guide. Am I right? Yeah, about Patroni Cooking Guides. So many speakers. Yeah, okay. Yeah. Okay, so perhaps you want to start the explanation about Patroni?
Yes.
Okay. Yeah. Then we can switch the screen. Yeah. Okay. Alif. Yeah. Okay. So perhaps you want to start the. Okay. So this is your last day, yeah, actually in Indonesia.
Yeah. Tonight I'm flying back to Berlin.
Yeah. So every one of you, if you have any questions, you can post your questions and prepare your questions. We will have a Q&A discussion after this. After Mr. Alex do some presentations about the materials and also perhaps some of demonstration, right, on Patroni. Yeah. So Mr. Alex, you came to Jakarta since Saturday, yeah? Since Saturday. How was your flight?
Good. It was a short flight from Bali.
Yeah. And after from Indonesia, from Jakarta, where do you want to go?
I'm going back to Berlin.
Go back to Berlin.
Go back home, yes.
Oh, go back home, yes.
My days are over.
How was your flight? Mr. Alex is originally came from Moscow, and then you moved to Berlin, right?
Right.
In about 2000 and
Going back to
perhaps
2013.
go back to Berlin. 2015, yeah.
Go back
home, yeah. Oh, 2013, yeah. You work in Berlin, and also Zalando, right?
Now I work for Microsoft.
No, previously.
Yeah, previously, yes. I worked like in Berlin, worked like mostly for Zalando, almost 10 years.
Almost 10 years.
It was like my personal record to be with one employer for so long.
Right. I know previously.
You know, usually IT guys switching jobs quite frequently because you want to get a salary.
Yeah.
I would say Zalando was treating me quite good.
Right.
Right.
Have you detected
You know, usually IT guys
did your laptop detect
quite
the
frequently.
HDMI?
It did not.
Not yet.
No.
Yeah. Or perhaps you want to have the presentation material from our laptop.
Then I won't be able to do like demo.
The HDMI? Okay.
It did not.
Because it is not detected.
That's weird.
Or perhaps you
Usually I
want
don't
to
have issues with HDMI cable.
have the presentation material from perhaps.
then I won't be able to do like them. Just check which input it's telling.
Because it's not detected. Yeah.
It's weird.
Is it okay?
Usually I don't have issues with HDMI cable.
Have the presentation material from perhaps.
Then I won't be able to do like them. Just check which input it's telling.
Because it's not detected. Yeah.
It's weird.
Is it okay?
Usually I don't have issues with HDMI cable.
Have the presentation material from perhaps.
Then I won't be able to do like them. Just check which input it's telling.
Because it's not detected. Yeah.
It's weird.
Is it okay?
Usually I don't have issues with HDMI cable.
Have the presentation material from perhaps.
Just check which input it's telling. Okay.
Okay.
What? Sorry.
Did it detect?
Yes.
Not yet. You can push it here.
Okay.
Okay.
What? Sorry.
Did it detect?
Yes.
Okay. So, yeah,
Can
it's
push
already
it.
detected here.
Second. I need to mirror
Yeah.
screens.
So while waiting to prepare the presentation, perhaps in audience in here can prepare the questions, especially for the technical questions. Yeah, because today we will talk more about the implementation of Patroni. Some of you perhaps already know about the implementation and already used on your production system. But perhaps you're facing some problems, some trouble, and also you want to know about how to troubleshoot and also perhaps tuning. You can ask the question here. We will have after this for around 1 hour. We discuss more, and if you have any questions that you might want to pose directly, you can raise your hand. Yeah, both people from this offline audience and also online audience. You can ask, yeah, because we will make this discussion become more interactively. Yeah. So if you don't want to miss the opportunities or the context, then you can raise your hand. Okay. Yeah.
All right. So
It's already showing here.
yes,
You can start.
Everything is fine, and we can start. So I think I don't have to explain about me anymore because like, we talked already twice about my career and like how Patroni was founded. Therefore, let's jump directly to the topic.
You can start.
Everything is fine. First, I will explain what Patroni is and how it works, like what are the ideas behind, and then like this all become very practical. Like I will show a live demo, like it's not mentioned here, but I will do it. I will explain about how to prepare, like to set up Patroni in your environment, like how to choose distributed configuration store, like HTTP console bookkeeper, like which one of them to choose, what is the difference. Then we will discuss backup and point recovery topics, and how it interacts with high availability. Then we will continue with configuration management, like how to tune and like what to tune in Patroni and Postgres configuration, and like how Postgres configuration is assembled by Patroni, because like it's very flexible and sometimes interacts with high availability, what and how it should be configured. And couple of last moments we will spend time on is setting up connection pooling, like debouncer, like what would be the proper place for it, and what are advantages or disadvantages of this solution. And the last one, but not also very important, it's about monitoring and troubleshooting the entire setup, because I get the feeling that sometimes people literally don't understand how to troubleshoot distributed systems, and it could be a tough problem. Like my experience is people stick to just single error in the log file, and they think that they found a problem, although this error might mean totally different and could be just consequence of previous failure. Okay, so coming back to the topic, like what Patroni is and how it works. Patroni is a tool to implement Postgres high availability. It relies on distributed configuration store that provides quorum. Do you know what quorum is?
How it works.
Please raise your hands.
Patroni it's a tool to implement Postgres high availability. It relies on distributed configuration store.
Yeah, do you know what quorum is?
Do you know what quorum is?
Please raise your hand, like if you know something about quorum or you know something about consensus and systems that
do you know what
provide
quorum is?
consensus, like quorum-based consensus, like HCD,
Please
Zookeeper, or
raise your hand,
Console.
like if you know something about
Okay, not so many hands.
about
The idea is
consensus and
we
systems
have
that provide consensus,
usually
quorum-based consensus,
odd number of nodes, like for instance 3, 5, or 7, and write to such system is only possible when majority of nodes accept the transaction. For instance, we are writing to the node which is on the top, and it sends write request to remaining 2 nodes in the cluster. And write will succeed when at least one of followers will accept it.
the node which is on the top, and it
If
sends write
the
request
leader
to,
node is
remaining
isolated,
two
like
nodes
the top one, then it
cluster.
will not be
And
able
write will
to
succeed
accept
when
the write
at
because
least one
it
of
cannot access
followers
remaining nodes.
will
And such kind of
accept
systems are called quorum system. And ATCD like implements implements it. And Patroni is relying on such distributed configuration store to implement high availability. So
systems are called quorum systems. ATCD like implements
okay,
and
I hope now it's better. Good. Right. So this is a typical Patroni setup. We have a primary node. On the node, we run Postgres, we run Patroni daemon, and basically that's it. And we have a replica node where we also have Postgres and Patroni. And between Postgres, there is a streaming replication, a physical streaming replication, which exists since many years, and Patroni relies on it. What Patroni does, it interacts with etcd, and the leader sends request to etcd saying that I'm still a leader, and on the standby node, Patroni can get information from etcd which node running the leader. It helps to solve many different problems. For instance, if you want to add yet another standby node, yet another replica, it can automatically discover which node currently is a leader in the given cluster, because this information is stored in etcd. It's very convenient. And to provide a single endpoint to connect to the primary, because like when we have multiple nodes, we don't know which one is the primary. You can use HA proxy, and HA proxy interacts with Patroni, and in order to know which node is running the primary, and sends a request to the respective Postgres instance. So what is distributed configuration store? There are like many varieties of them. Console, etcd, now it's only version 3 is which is maintained, version 2 is deprecated. However, so what is distributed configuration store? There are like many varieties of them, version 2, and it will be working just fine. Patroni also supports Zookeeper, and Patroni supports Kubernetes REST API. So you can deploy Patroni on Kubernetes natively, and Patroni makes Postgres cloud native before it became mainstream, I would say. You probably some of you heard about cloud native Postgres operator, and Patroni does it for like much longer. Yeah, distributed configuration store helps with service discovery because every node, Patroni and Postgres node register themselves in DCS, and therefore it's possible to discover the entire cluster state. There are a couple of very important properties from configuration stores which we are relying on. depending on type of configuration store, we are relying either on lease, session, or TTL mechanisms to expire data, to expire keys. For example, we want to expire leader keys if key if it is not updated. And the second, but actually, in terms of importance, the very first property which we rely on, it's atomic compare and set operation. If we explain it in simple words, a configuration store provides the ability to update keys only when some specific property matches your expectation. For example, you say, I want to update the leader key only if current value stored in the leader key matches this the provided value in the REST API operation. And the rest is being solved by DCS for us. And the last one, which is also important, but we maybe can live without it, it's watches. What does it mean? We may start watching for changes on the key or set of keys. And in case if they will get some updates, we will immediately get notification that key has changed or expired, and Patroni also relies on it. So how Patroni works? This is a typical Patroni or Postgres cluster with one primary and two standby nodes. And we are using in this example ATCD as DCS. Patroni on the primary node periodically sends update requests to ATCD, and it updates the leader key. In the update operation, we specify that we want to update key name with the name leader. We want to put value A, but update must succeed only if the previously stored value in the leader key is also A. That's important. That's a compare set operation. And we set TTL for the leader key to 30 seconds. At the same time, standby nodes just watching for changes of the leader. That's important. Immediately receive notification, or in case if key will be expired, they will also receive notifications. So what happens if primary node crashes? It disappeared. Like Patroni isn't running, Patroni cannot update leader key in ATCD in this case, and TTL on the leader key starts to expire. On this slide, we have TTL which is 7 seconds, and in 7 seconds, TTD will move the key, and TTL on the leader key standby nodes, like Patroni on standby nodes, get notification that leader key has expired, does not exist. And at this moment, standby nodes recognize that leader, there is no primary anymore, and they need to start a leader race. It's really a leader race. It's not a leader election, because every node goes through there is no primary special function that is trying to determine whether this node should become a new primary or it should dismiss itself from the leader race. And how it's implemented. Every node does, first of all, REST API requests to all existing nodes in the Patroni cluster, including the formerly non-leader, which is also important, because let's imagine that old leader just cannot access DCS anymore, and therefore update leader. Maybe Patroni and Postgres are still running and they respond on REST API requests. That's why it's important also to check that it's not accessible anymore. And node B connects to node A and node C on the slide, and from node A it gets timeout or failed, or request just fails, and from node B it gets From node C, it gets a response with current write-ahead lock listen equals current number. On this slide, it's 100. The same type of request does node C. Like it tries to connect to node A and tries to fetch information from node B. And connection to node A also times out, and node B reports its LSN 100. Means that both standby nodes manage to replicate data up to the same LSN and they're on equal position, and it means that they may try to grab the leader lock to become the new primary. In case if one node is ahead and another node is behind, the node which is behind disqualifies itself and it will not try to grab the leader key. In this case, like both nodes, like B and C, on the same LSN, and therefore they're trying to grab the create the leader lock in etcd. They send a request to etcd. They're trying to create a new key with name leader and value which matches their name. So node B tries to create a leader key with value B and node C with value C. However, like here we are also relying on the fact, relying on the compare and set operation. We are asking etcd to create key only if currently it does not yet exist. It will make impossible to that two nodes concurrently create and overwrite leader key. On this slide, only node C managed to create a leader key, and request from node B failed with the error message that key already exists. This is like also a very important moment about how Patroni works. After node B, node C managed to create leader key, it promotes Postgres, and Postgres becomes a primary, and node B discovers from etcd that node C became a new primary and updates its configuration, primary parameter to configure Postgres and start streaming the new primary. Maybe it's a good time to show how it works in practice.
Its configuration, primary parameter to configure Postgres and
Yeah, I will make it a bit bigger. Just, and I also need to change it from black to white probably. Otherwise, I know that it's not very visible.
I will make it a bit bigger.
And I also need to change it from black to white probably. Okay, so let's switch back to the slide where I tried to explain it. It's better that the node which received the more transaction log, like more transaction received or replaced transaction logged up to a bigger point, will become the leader. And to determine which one managed to receive more, we are not relying on just solely etcd. Like nodes are connecting to each other and making API requests. Like node B knows that I managed to receive LSN up to position 100, and it connects via REST API to node C, and node C says I also managed to receive write-ahead log up to 100. It means that they're on the equal position, and both of them are eligible to become new primary. And but they don't promote until they create a new leader key in etcd, because like only the node which owns the leader key is allowed to be running as a primary. So this is like how race condition is being solved.
Until they create a new leader key in etcd, because like only the node which owns the leader key.
Yes. Like this is pure. Like in this case, it's purely by chance. Like which one managed to make request to etcd faster. Like in case if let's say node B has received write-ahead log up to position 101, but node C up to 100. Node C will not even try to create a leader key in DCS, because it knows that node B is ahead of me, and therefore only node B will try to create leader key.
Node C up to 100. Node C will not even try to create a leader key in
It's a Patroni itself, and Patroni itself runs on every node independently, and every node makes a decision on its own. So it's very decentralized. It means like we don't have Patroni running somewhere and making decision for everyone. Patroni runs on every node and making decision just for itself. That's a very important moment, because if you have a central component that makes decision, it becomes a single point of failure. And in case of Patroni, everything is very symmetrical, and there is no single point of failure. That's a biggest advantage, in my opinion.
If you have a central component that makes decision, it becomes a single point of failure.
Let's start
Patroni, everything is very
Patroni cluster.
There is no single point of failure.
Should I make it even more bigger?
In my opinion, if you have a central component that makes decision, it becomes a single point of failure.
Let's start
Patroni, everything is very
Patroni cluster.
There is no single point of failure.
I'm gonna use Docker Compose to start Patroni. It's just simpler for this presentation. So I'm starting with a single command etcd cluster, which consists of 3 nodes of etcd, like etcd1, 2, and 3, and a Patroni cluster, which consists also of 3 nodes. And besides, there is also a node which is called Equnix. Now we can check logs of one of Patroni nodes,
2 and 3,
and
and
one
the Patroni
example,
cluster, which consists also of 3 nodes.
Patroni 1
Besides, there is also
currently running as a secondary, and Patroni 2 is running as a leader. And when they run, they throw messages like I'm the leader running with log, and other will show different messages.
And when they run,
Patroni 1, like they're saying I'm running as a follower and following the leader, which is under name Patroni 2. And the current primary is Patroni 2, like this one. Yeah, it's left top side. This one. Yeah. Yes.
the current primary is Patroni 2.
On the right side is Patroni 1, and Patroni 3
Yeah,
would be
it's
left
top side.
this one. Yeah.
Yes. The current primary is Patroni 2.
On the right side is Patroni 1, and Patroni 3, yes, would be left
top side. This one.
Yes. Like every instance runs inside one container, and like it's just it's a REST API and received a response. In the response we have LSN. Yes. So like it contains way more data that I showed on the slide. And we have received location, a replayed location as in long integers, and those are used to figure out which node is ahead of which one. And it got a timeout from Patroni 2, which was the former leader. So it says request timed out after 2 seconds. And after that, it sent request to etcd to create a new leader log and promoted Postgres. So promote happened, and now it says I'm the leader with the log. We can also check logs from the node which failed with leader election. So it did very symmetric response. It got a timeout request from Patroni 2, from the former leader, because it's dead already, and it tried to create a leader lock in etcd. However, it happened almost at the same time with Patroni 1, and this one didn't manage to get the lock. And I'm trying to highlight this error, like not error, but info message. I hope you can see it. Like, could not take out TTL lock, because it also tried to create a leader key in etcd and failed because the other node was faster. Like, it helps to avoid rate condition and promote to more than one node to the primary. After that, it realized that we got a new leader, Patroni 1, and it updated primary coninfo, put IP address of another leader to primary coninfo, and now everything is running back stably. We can again check with Patroni control list, the current cluster state. We have just two nodes. One is a leader, the second one is a replica, and it is streaming. And timeline was increased to 2. Like, it was 1 before, and now it's the timeline 2. We can also try to start back Patroni 2. Start. So I'm gonna start the failed container, like containers that we killed, and Patroni does all necessary things in order to join it back as a new standby node. And in case if required, it does PG rewind, which is also very important because it may be very huge database, multiple terabytes, and rebuilding it from base backup will take many hours. And PG rewind allows us to quickly get back the failed primary as a new standby. So in this case, Patroni figured out that we need to run PG rewind. It executed PG rewind, and now this failed primary is running as a standby successfully, and we can check it in the Patroni control list. Yes, Patroni 2 is running as a replica successfully.
Okay, so actually, when we need to previously done, and it will,
yeah,
connect to the previous leader. Then when one successfully become the leader, then the Patroni services inside Patroni 3 will change the primary input to Patroni 1.
Yes, correct.
Then when you try to become previous leader,
yes,
you can use PG1.
Yes.
To reconnect to the new leader.
Yes, exactly. That's what's happening, and it works quite reliably. Of course, there are cases when PG rewind cannot do its job properly, maybe because of bugs, maybe because of some other problems. Like, we cannot guarantee that it will successfully reconnect the former primary as new standby in 100%, but like, it's very close to 100%, I would say. And in case of PG rewind fails, it's also configurable what to do. You may configure Patroni to fully rebuild such standby on rewind failure, or you may, or by default, Patroni keeps it intact in order, like, if you want, maybe like this is the last copy of your precious data, and you don't want to drop it by accident, and this is. Like, it's all configurable. Okay, so I think we can continue this presentation. Like, in the demo, I was using etcd, like protocol version 2, but the typical question I get from people, what type of distributed configuration store they should be using. And rule of thumb is very simple. Like if you have already something what deployed is in your organization, just use it. Nowadays, it's very common that people have one of them, maybe console, maybe etcd, maybe some people still use Zookeeper. And in case if you have something, just use it. Like you don't have to do it from scratch. You don't have to build new things. You don't have to understand how it works, because some other people already set it up and taking care of such a distributed configuration store. If you have nothing, my recommendation is to stick with etcd, because it's, in my opinion, more reliable and more flexible in regard of how Patroni can communicate with such a system. So, like, what is a like why I don't recommend console? I will explain a bit later. And with Kubernetes, it's so obvious. Like if you deploying Patroni on Kubernetes, that means you already have Kubernetes, and you don't have to choose, because like it will be used automatically. Yeah, and one friend of mine working for very big organizations told me that they run something like 6,500 Patroni clusters. Every cluster consists of three or four nodes, and it's all backed by a single etcd cluster. So like etcd is very scalable, and it's hard to imagine that in many organizations you run Postgres at such big scale, like with thousands of Postgres clusters. And the single etcd cluster can serve all of them. So general tips, like when you're setting up distributed configuration store, and like when you when you run in Postgres, make sure that your hardware clocks between different DCS and Postgres nodes are in sync. It's very, very important. Like for Postgres, it's important for replication, because replication involves sending ping and feedback messages, and in case if clocks are not in sync, you may get some inconsistencies in views. And in case if clocks are not in sync between etcd nodes, side effects are also very bad. etcd may start to expire some keys earlier, or it may trigger sudden leader election within etcd and behave very unstable and unreliably. Better to run distributed configuration stores on nodes which are different from nodes where you run Patroni and Postgres, because all like etcd console and Zookeeper are very critical to IO latency, and Postgres may generate a ton of IO, and it may impact distributed key value store. If you cannot separate from Postgres, at least you better provision a dedicated volume, like on dedicated device for etcd. It's a good idea to protect your distributed key value store, because by default, like when you start etcd, you can make unprotected requests. You can wipe all keys. You can do anything you want. In the best case, you need to use client and server certificates and passwords. Maybe like if you providing database as a service, and you create and run Postgres clusters for different clients, and don't want one client to be able to access keys that belongs to servers of other client, you want to configure role-based access. It's possible in etcd to configure access, but like role-based access. You say for user A, I'm giving access to only this subtree of keys. It's a good thing to do. Like you don't necessarily need it, but in case if you do, you can do it. It's not a property of Patroni, it's property of distributed configuration stores. Console, as I promised, console is actually very advanced distributed configuration store, and it provides more features than just this. Like my general recommendation, you shouldn't be running Patroni on console server nodes. Like console is a very complicated system, and you run console server nodes somewhere, and on every node with your applications, you run console agent nodes. And Patroni should be running on nodes with just normal console agents. That's not very nice from perspective of Patroni, because Patroni can work only via local agent in order to communicate with console server. And it means we have no control and cannot retry requests in case if they fail by switching to a server which probably is alive. With console, it used to be a problem that by default some checks were employed which caused session invalidations. Now Patroni does good things and removes console checks and sets it to empty value by default. In case if like you still for some reason run Patroni on console server nodes, what may happen that there is a network blip and it causes raft reelection inside console. And because of that, console invalidates all keys that were created, all sessions that were created on this node, and it may cause a failover, which is not nice. That's the reason why it shouldn't be running on server nodes. Like with Kubernetes, it's very simple. Like you just deploy Patroni on Kubernetes using either like one of existing Postgres operators. I wouldn't recommend doing it manually because it will require you to write a ton of YAML files, and people in general not very good in writing YAML documents. They're huge. Like Kubernetes YAML documents very huge. I would prefer using Kubernetes endpoints to config maps, because endpoint contains information about which pod is running as a leader, and subsets of endpoint are updated atomically with a leader, like with a leader race. That's a big advantage. However, like when you run on Kubernetes, you can use also external DCS like ATCD. You can configure Patroni to work with external DCS, but you need to implement some callbacks to set pod labels. Okay. It's also possible, but maybe not desirable. The very frequent question up to like 2 years ago, I was getting, why Patroni decides to demote primary when it cannot access etcd. You remember like, the very top slide when Patroni is sending update to the leader key every 10 seconds, and like standby nodes are watching that leader key exists. And in case if Patroni running on the primary sends an update and update fails, Patroni stops Postgres and restarts it in read-only. Because why it does it? Like it's called self-fencing, and the reason why key in etcd could not be updated is unknown, and we are in an undetermined state, and we don't know like whether it's etcd is down or maybe we cannot just access etcd, and remaining nodes maybe already went through a leader election process and elected a new leader. We want to avoid split brain, and therefore primary demotes. And people didn't really like this behavior. And now it's possible to have what we call fail-safe mode. Fail-safe mode allows to keep primary running when distributed key value store is temporarily down. But requirement is that primary must be able to access all existing standby nodes.
So the leaders should check all the replications that running, right?
Yeah.
Even
so
if the DCS
maybe this one I can also demo. We need to enable fail-safe mode. Fail-safe mode on in the configuration. It takes a bit of time until it will be applied. And now we can docker stop demo etcd1 and demo etcd2. Like we stop 2 nodes out of 3, and therefore etcd will lose quorum. It will not be possible to write to etcd. So now 2 etcd nodes are stopped, and we start seeing some errors in a few seconds. So we are looking at Patroni logs on the primary. It is trying to access etcd and fails. It does a few retries, but after 10 seconds it gives up. And as a fallback mechanism, it is connecting to remaining Patroni nodes, like Patroni 2 and Patroni 3, and they say, I accept that you continue to run as a leader. And the leader writes into its log, I'm continuing to run as a leader because fail-safe mode is enabled and all members are accessible. So now Patroni can survive.
What happens if one of the standby or the replica cannot be accessed by the
in this case, primary will demote.
Will demote.
Yes.
And then after the primary demote, is there any like the replica which could be promoted?
So after that, like it will require etcd to become healthy again, like in order to resolve automatically. So okay, let's go back to slides. But at least now we can like exec. So Patroni control list will not really work because etcd is not accessible, but we can try to connect to the leader. 08 password is Postgres, and select pg is in recovery. Yeah, so like it's running as a primary,
right?
So it did not demote, although etcd is not accessible. And if we can after that start etcd nodes back and logs, Patroni logs going back to normal. So like temporary outage of of all DCS could be resolved by Patroni without demoting.
So DCS become the critical point that
yes, it's very critical point because we rely on DCS to detect network partitioning. Because like the typical problem, like we have like now you can see me, but let's say if I cannot see you, like there are 2 outcomes why it could happen, because like you went away somewhere, like now this place is empty, but I don't understand that, like you are not here, or maybe because like connection between us is broken. Right. So and we cannot distinguish between 2 cases without involving someone else. Because you may ask only the third person to confirm, like, are you still here, or it's just internet connection broken. And etcd and like all other consensus systems, they allow to detect and resolve such problems. And
so we can
like
assume actually
you can know that like this node is isolated, like in the network, like it's not something different that like all other nodes are dead. Like it can tell for sure that like I'm isolated. Okay, so now coming back to backup and point-in-time recovery. Many people think, why do I need backups if I run highly available cluster? I have primary, I have replica, like, and then if primary failed, I will just promote the replica. And I have very bad and sad news for these people, because HA is not a replacement for backups. Really, there might happen very unexpected situation. It could be bug in Postgres, it could be bug in your application, it could be just human error, like that connected to a database and dropped some very important tables, and you want to restore your data. And and in case of replication, like all your actions are immediately replicated to standby node. You drop your table, and it is also done on standby. And you need to use some real backup tools. And I listed some of them here, like the one that goes together with Postgres is called PG-based backup. Patroni can use it by default to set up replicas, but it cannot do backups and implement backups and point recovery for you, like just inside Patroni. You need to configure something like PG backrest, Volgy, or Barman separately. Put these backups to some safe place, like S3, Azure storage, or like some other data center, and make them accessible from all nodes. And you also have to enable continuous archiving. Like archive mode must be set to on, and you need to set up archive command and restore command. In case if there are replicas that have in their text clone from tag, then such replica will be considered to get backup from. It helps to reduce load on the primary and makes your system more stable and reliable.
Okay.
Yeah, so this one actually has to be updated, but it's still probably nice to have. It's very typical question up to recent releases of Patroni was, while some nodes are down temporarily, they get deregistered from DCS, and Patroni on the primary removes the replication slots for these nodes. And it means write-ahead block is no longer reserved, and when you resurrect those nodes that were temporarily down, that they connect to the primary and start getting errors that wall is not accessible anymore. One of the typical answers to this problem was, please configure backup and point-in-time recovery. So, like if wall is missing on the primary, you can still fetch it from the archive. And it is, in my opinion, it is still preferable way. However, like you can define permanent replication slots in Patroni. This one has to happen not in the local YAML file, but you need to do it using Patroni control edit config tool, because it is stored in the configuration store. You just declare all nodes that exist in your cluster, and you need to like and name for replication slot must match the name of your node that you run. And while nodes are down, primary will not drop replication slots for such nodes, because those are declared as permanent. In the latest release, we did a little improvement, and it's possible to separately configure retention for replication slots for members. So by default, it will keep them up to 30 minutes, but it's possible to increase this value.
Okay.
Yeah.
So perhaps you can go faster, because
yeah, sure.
time is already 10 minutes left.
Yeah.
Okay.
So yet another feature which could be implemented using archive and backups, it's a custom bootstrap. Like while doing live demo, I just set up the whole cluster with one click, so to say, and one of Patroni nodes became a leader, and it initialized using initDB, like it's a default method of initialization. However, like if Patroni gives you a possibility to create a new cluster from base backup instead of using initDB. It's a very good and efficient tool, like in order, because it allows you to create a clone of your existing cluster for testing. It allows you to test backups, like that your backup solution is really work, and you can restore it using this backup. And something like this. And in order to configure it, like you can use bootstrap section in Patroni YAML file. You say, I want to use backup method, the name, just random name you would like to declare. By default, it's using NDB, and you need to declare a section which matches this name, where you put all configuration for your custom bootstrap. It's very hard to explain on the slide. It's better to read just in the documentation.
Right.
There are more examples how to do it correctly. I know that many Postgres operators are using this and utilizing this feature to create clones. Okay, now about configuration management, which is also a very important topic. Patroni has its own configuration. Postgres also has its own configuration, and Postgres configuration, some Postgres configuration parameters must be managed by Patroni. Therefore, like, we provide a very good flexibility, like how everything works. Some parameters are coming from global configuration, global dynamic configuration, which are stored in etcd. It makes it possible to have the same values of configuration parameters applied to all nodes. For example, we want to have max connections on all Postgres nodes set to the same value, and therefore Patroni requires to have max connections in the global dynamic configuration. Such configuration could be changed only using the Patroni control edit config tool, or using or by doing REST API requests. There is also a local Patroni configuration, which where you can set configuration parameters which are specific for this node, like depending on its size. Let's say you have a lot of CPU power and a lot of memory, you can increase like workmem parameters to do some heavy calculations. And some configuration for Patroni could be also set from environment variables. I don't know like if many people do it, but it's possible. Let's look a bit on practice how it works. We have in etcd in the config key stored something like Postgres parameters workmem 16 megabytes. In patroni.yaml we have workmem set to 12 megabytes, and in the PostgreSQL.conf, which is generated by Patroni, we will have workmem 12 megabytes, because the local configuration has a higher precedence than configuration from etcd. At the same time, you may still use alter system, like some people find it handy, but I prefer to avoid using it. And like if someone used alter system, then it will be applied value from the alter system, like 24 megabytes in this example.
How about the VIP configuration? Because how about the VIP configuration? Because you know that on previous slide we have like 3 nodes, and then how the application can reconnect to which IP if some
So I will explain a bit later. There are some exceptions about how Patroni manages configuration. Some parameters could be set only globally, like max connections. It's very important. And some Patroni parameters that could be set only globally. Like those are listed here. In fact, maybe there are some new parameters like added in the latest release, but it's all very, very well documented. It's very good, very interesting catch that people sometimes trying to change max connections and restarting Patroni and don't get in result they expect. Max connect, like to change max connections, we need to use Patroni control edit config. In this example, we increase max connections from 100 to 101. And when increasing max connections, we have to restart standby nodes first. And we need to do it using Patroni control restart, like first standby nodes and then primary node. However, when decreasing max connections, we need to restart primary first, because Postgres does not let you run standby with max connections value, which is lower than on the primary. That's why, like, when decreasing primary first must be restarted. And it needs to be done using Patroni control restart. Like, if you just restart Patroni, it will cause a failover and max connection will keep the old value. Only Patroni control restart or REST API request that does it. Many people caught by problem of not understanding how global configuration works. Patroni, when the new cluster is set up, allows you to set some default values for global configuration, which will be written to etcd. But it happens only when new cluster is initialized. It's necessary to have very flexible declarative configuration. But what people do, they trying to change Bootstrap DCS section, restart Patroni, and see that nothing is applied. They must use Patroni control edit config. If they just update this section in local configuration, it's useless. Like, we put these comments in Patroni YAML files in the repo, but the people seems not to read them, and still falling into this trap. Yet another problem that people have, Patroni, like, when register in etcd, needs to declare how this specific node could be accessed from other nodes. Like, we cannot put something like localhost to connect address, because, like, while connecting localhost, you are connecting to you cannot reach the other node. And therefore, connect address must be accessible from, like, anywhere in your infrastructure. Like, if there is a local host, it's a big problem. There are some aspects of security you need to think about. Better to protect Patroni REST API, because it allows you to change any kind of configuration and do anything with Postgres. Better if you set up some basic auth, but even better if you use client and server certificates to protect Patroni REST API. Also, like, in DCS, you can define Postgres configuration. For example, you can change archive command, restore command, and so on, which will cause executing code on the Postgres node. Like, if attacker managed to get access to DCS and set something like archive command, it will execute arbitrary code on your Postgres node. This is something what you avoid probably, and better, like, if you protect your DCS. But I said about it earlier, like, you better protect it with client and server certificates. So how to connect to primary? Like, that's your question.
Yes.
Yeah. Let's say we have applications, like multiple of them, that just set up to connect to the primary. And when primary is down, application get an error. Connection is not possible. And what people typically do, we need to update connection string in all applications, restart all of them, like, and point to the new primary. That's not how it should be done, and there are multiple options to implement it. The very obvious one, like, and actually very flexible, not sure, like, if it should be recommended one. We can put multiple hosts in the connection string, and we rely on the feature of either JDBC or libpq that allows us to specify target server. Like, we specify in JDBC connection string target server's type primary, or in case if it's a libpq based application, we can specify target session attributes read write. And basically, out of these nodes, it will driver will connect to all of them, and like, you'll pick the one that accepts read write connection or running with the primary.
Okay.
That's a very simple one. If we need to do something more complex, there is a virtual IP manager from Cybertech. You need to run it on all Patroni nodes, and it will attach virtual IP to the node which runs the primary. Yet another option, Patroni supports callbacks, and it may run custom scripts when it starts, stops Postgres, or promotes Postgres,
Okay.
or restarts Postgres. And in these scripts, you can also do such virtual IP management. In my opinion, it's not the best thing to do, but in case if you have no other option, you can still use it. And what is a recommended way, which allows us to solve more problems that are accessing just a primary node. We can run HA proxy in front of all Postgres clusters. HA proxy, it's a TCP proxy that does load balancing based on REST API checks or any other kind of health checks. And HA proxy interacts with Patroni, and it knows which one is running as a primary, and therefore may automatically send requests to the primary node. In case if primary changed, the HA proxy will reopen TCP connections to the new primary.
Okay. So application only connect to one IP.
Yes, right? Exactly. So application just need to connect to HA proxy. And the other very nice thing about HA proxy, it allows us to do load balancing between standby nodes. Okay. Because Patroni implements different kind of health checks, and you may configure HA proxy to also run such health checks to pick, for example, standby nodes or synchronous standby nodes or asynchronous standby nodes. You may also specify, I want to pick standby nodes that are not lagging behind more than 10 megabytes, something like this. It's very flexible.
Okay. Okay, sorry. Before we continue, I think we already running out of time, and I want to open questions from the participant here. So because we already talked about how Patroni is configured and how Patroni can manage the failover mechanism. So perhaps any one of you from audience in here, in offline and also from online, do you have any questions that you want to pose? We will open the first two questions from offline participant. Do you have any questions? You can raise your hand. Any questions? No questions at all? Okay, yes, please. Please stand up and introduce yourself, Pak. Oh.
Yeah, it's a good question. Once I made an attempt to implement Raft inside the Patroni using one of Python libraries implementing Raft, and it is available, it works, but for some people it seems to be not very reliable. I know that some people are running Patroni with built-in Raft very successfully without any issues, without no complaints, and it worked for them. Like it is still like built-in in Patroni, like it wasn't removed, but we declared it as how to say it, like unsupported. Like in case if you get into troubles, there isn't much we can do because of the quality of original Python implementation of Raft. It does not have very good logs. It does not allow to understand what exactly and how it failed and how it could be fixed. That's unfortunate, but like it is still built in Patroni. Like we still maintain it. Like in case if we add some new features, we take into account that we need to also update this built-in Raft implementation. You may you may find examples how to use it in Patroni docs. You may try it. Like and in case it works for you, please use it. But please keep in mind that like if you hit some problem, very likely I will not be able to help with it.
Okay. Does that answer your question, Pak? Okay. Any other participant who want to pose some questions? No? Okay. I will read some questions from our online participant. From Pak Heri Liu, he posted on Zoom. The question is related to Patroni REST API. Pak Heri tried to test the read-only latency by calling /replica and /async. Wondering why calling /replica the latency is more stable compared to /async.
I'm not sure if I understood it. Maybe you can show me.
Yeah, this one is /replica and /async.
Latency. I'm not sure like what kind of latency do they mean, because HA proxy does not add any latency, and like if they talk about some latency reported by Patroni REST API to logs, it's only about latency of this request, and like it does not change effectively anything. It could be like half a millisecond or millisecond. So probably better to rephrase the question. Otherwise, I don't know how what to answer.
So the condition is not related, about the latency and also from calling the
so like HA proxy itself does not add much latency. That's my answer. Because like you may have some latency on the replica node, but it's not always possible to measure it correctly, and like such latency depends on the type of queries you run. And like if the question is about latency reported by Patroni, like when executing some REST API requests, like health check requests, well, it reports some latency, but it's just only for informational purposes. It does not really represent latency that you get from Postgres. So this is just like time that took Patroni to execute REST API request, not more than that. So that's why I'm asking, like maybe they should rephrase the question.
Okay, so perhaps the question is not really relevant, about the latency on also
I don't
calling
know.
the
So
API,
like
right?
maybe they should try to rephrase it.
Okay, yeah. Okay, another questions from YouTube. Can you show me the questions? Okay, question from Mr. Bambang. How can we assure that HA proxy is reliable to keep uptime 100%? So if the HA proxy down, they automatically restarted as fast as it can. How can HA proxy make, because HA proxy becomes the HBOS, right?
That's a good question, and I even have slide for it.
Okay, you want to show the slide?
Yeah, so please.
Okay.
That's really good question. Like one of the obvious thing to do, you can configure your system D unit to restart process in case of it crashed. That's things that you must do, like with HA proxy and with Patroni. However, like HA proxy still becomes a single point of failure because it's running still on a physical node. And solution, you may run multiple HA proxy instances on multiple nodes. And you can do load balancing between them by putting all IP addresses into DNS. Like a single A record may have multiple IP addresses. And there is also a way to use sort of virtual IP by using TPL-IFD. Basically, TPL-IFD will assign a virtual IP to a node where a live HA proxy runs. And configuration for TPL-IFD is also available in Patroni repo. I hope it answers the question.
Okay, thank you for answering. Pak Bambang, could you please also post that which company you are from and from which institution, perhaps company or institution, then we can also know Pak Bambang is from what company. Okay. Another questions perhaps from audience here or from Zoom, From Zoom, okay. Also from Zoom, please also post from which company you are from. This is from Pak Hari Santio. Good morning, Alexander. As far as I know, that Patroni requires multiple ports to be open for communication between components such as 5432 as a standard port, 8008 for the API, and 2379 or 2380 for HCD peer or client ports, and also HA proxy on some occasion. Is there any development recently that comes up with the reduction of the port, since it's quite a lot of resource usage? Thanks. So he's asking about too many services. We should
Yeah, so
configure.
like this amount of ports is essential. I don't think we could really reduce it. In fact, the TCD like accept requests on two ports, like by default, 2379 and 2380. Like 2380 is used for server-server communication, and like 2379 to accept for client requests. But like this port only for etcd. Patroni itself, yes, uses REST API port, and like it must use it, and like we cannot avoid having REST API in Patroni. And Postgres, of course, runs on by default on port 5432. Like we cannot also close it. It's impossible. HA proxy, it connects us to Postgres and need access to Patroni REST API. So I don't think it's like a lot of different ports. Like we cannot reduce it.
Because I think because
even if you run Patroni on Raft, like with built-in Raft, it will still open REST API port, like which is, by the way, configurable, and it will open a special port for Raft requests, because like Raft communication doesn't happen via Patroni REST API.
Yeah, I think this is because let me try to elaborate more. Yeah, because we have actually on PostgreSQL so many options to configure HA, right? The first one, the options that we offer about Patroni.
So then, like, let me put it differently. Like managing TCP ports, like much simpler than distributing SSH keys between nodes. What is required for other HA solutions to work, because they really access via HTTP, not HTTP, SSH key. Yeah, so they access via SSH and execute something like gcontrol promote via SSH. Like, and distributing SSH key is way more challenging a task to do correctly.
Yeah, okay. So let me try to elaborate also, yeah. Because for example, we have another options like using pacemaker and crossing, for example, like that.
Yeah.
Right. So we have to configure only one pair, master and standby. Right. Master and standby, and then we just run the heartbeat from standby to master, and then if master failed, then the crossing or the heartbeat can detect, and then pacemaker can do some promotion.
Yeah, the question is like which ports under the hood pacemaker use. I'm pretty sure like it's using something else, not Postgres ports.
No, I mean like this. I mean the Postgres itself, yes, the Postgres itself for that listening address, and then also the other ports is only communicate the heartbeats itself, only like one or two ports. Now, actually, the question is actually about the how many services that we have to configure. Since from Patroni, we have to configure like HA proxy and also HCD. And if I'm not mistaken, HCD becomes a witness, right? Witness and judge.
Yes.
To manage or to prevent split brain condition.
Yes.
Am I right?
Correct.
So how can we compare between this kind of topology and the other topology that only requires like only pair of instances and does not require any like of witness?
Like if we don't have a witness, any kind of witness, it becomes very unreliable in terms of you need to implement a very reliable stoning mechanism.
Yeah, stoning, right.
And in case if you cannot access the other node, it means like either this node is dead or some problem with your network communication. And implementing stoning one way or another requires you to have a good network, like maybe a second network channel. How can you make sure like that the second network channel is still alive? Implementing a very reliable stoning, it's a very challenging task. And without having reliable STONIT, it's impossible to have HA with just two nodes. Maybe you can do it within a single data center, but like in general, HA better to run like nodes within in different data centers, like in 2 or 3. And if we run nodes into different data centers, implementing proper STONIT, nearly impossible task, I would say. And ATCD or other consensus systems actually taking off this task from us. Like we know we can distinguish between node being down or node being accessible by just making write request to ATCD. Like if we running as a primary, making request to ATCD and this request fails, it means like we cannot write to ATCD, and that means like we are isolated, and the rest of the nodes maybe already got a quorum and selected a new leader.
Okay.
So, and with just two nodes, it's impossible, like without having witness.
Okay. So this is also, we have another question that related that when you mentioned about different data center sites. Okay, this is question from Pak Fendi Purnomo. He's from Icon Plus. What strategy, topology, or architecture should be applied when implementing Patroni across both a primary data center and a disaster recovery center?
Well, it depends on the needs, I would say. The very basic options that you can do, like you have one Patroni node in primary data center and another Patroni node in the second data center, but you need to put ATCD node in some third data center. Like it could be very cheap, very small node in some from some hosting provider, but it needs to be in some third data center. That's one option. The second option, Patroni allows us to run a primary cluster and a standby cluster. The advantage, like you will have two Patroni clusters that runs independently, but disadvantage that you, in case if you want to promote to a secondary data center, it has to happen manually. And we cannot do much better like without having a third data center, or we can, or like currently there is no mechanism to convert standby cluster automatically to a primary and the old primary to a standby. I hope it answers or gives some ideas.
Okay.
In the Patroni documentation, there are actually outlined possible deployment setups between different data centers.
So you mean like we have Patroni clusters on both sides, but running independently? Or
yes. Like we may have a Patroni primary cluster, like with one primary and multiple standbys.
On the main data center, right?
In another data center, we may have Patroni standby node cluster, which will be replicating from the primary. And only one node of the standby cluster will be replicating. The other nodes will be replicating from standby leader.
Okay, so
that's
like
also a viable topology.
Using cascading replications,
yes.
Right?
Yeah.
Okay.
And such standby cluster could be promoted to the primary cluster by just updating configuration.
Okay.
But it does not happen automatically because we cannot know like the state of the primary cluster from the standby perspective.
Okay.
That's why right now like it's uploaded to the human.
Okay.
Because it's a person who makes a decision to promote standby should STONIT the old primary, otherwise we get split brain.
Yeah. Okay, got it. I hope we can answer your questions, Pak Fendi. And then, do we have any other questions from audience here? Yes, please, Pak.
Yeah. Well, in general, HT proxy, it's a very stable and reliable tool. If you run in your own data center, like I would recommend you to stick with HT proxy. Like it's used by many people in the world. In case if you using some cloud providers, you may consider using some sort of load balancers provided by cloud providers. For example, on AWS, it's an elastic load balancer. Like essentially, it does the same thing. It can send health check requests to your to Patroni, and based on health checks, it sends TCP traffic to Postgres. Like the alternative exists on other cloud platforms, on Azure, on Google, and so on. Actually, one of the options which I know people sometimes use, but like it works only to connect to the primary. You may just stick with KPL-IFD because KPL-IFD is also capable of sending health check requests, and you run KPL-IFD on all Patroni nodes, and it will assign virtual IP to the node which runs as a primary. That's why. So it's like alternative to CyberTech IP manager. Like in case if you really need to have a load balancer across replica nodes, HA proxy, or some load balancers. I know that there are even hardware load balancers which could be used, like a 5 load balancer, maybe something else. I'm not so much into a hardware stack, unfortunately. Sorry?
Envoy. Can you Envoy? Envoy.
Well, it should be usable, but it's probably much harder to configure comparing to HA proxy. I know like that Envoy is very flexible, and it was mostly targeted to be deployed on Kubernetes and solve the service mesh problem. I didn't try to play with it, to be honest. In case if you can configure it to do health checks and configure like to which port send Postgres traffic, it should also work.
Okay.
Because like with HA proxy configuration is very simple. Like it's literally like 20 lines. That's it. With Envoy, it could be probably way more of YAML code.
Okay. Does that answer your question, Pak? Okay. We have another questions from YouTube, from Pak Budi Hartanto, PT Sadana. Protecting the DCS which stores Patroni or Postgres configuration is crucial. What is your recommendation about this? How perhaps he asking about how to protect DCS? Because this is very critical since it becomes
right. So like in DCS, we can keep Patroni configuration, and like let's say under Postgres parameters, someone puts archive command, which allows executing arbitrary shell command on the server, and basically like all of them must be protected. Like with etcd, better to use. With etcd console and Zookeeper, better to use certificates and maybe like some user and password on top of that. Like with Kubernetes, if you are inside Kubernetes, Patroni pods usually are already limited to access some resources. Like it is solved by operators, like by Kubernetes operators. In case of etcd, let me find where it was. I had a slide regarding
protect the DCS.
Yes. Right. Yeah. Like I would say all of them should be protected. Like in case of Kubernetes, you cannot do much, but even in Kubernetes, there is a way to limit what kind of objects inside Kubernetes could be accessed from where. Like better to be as strict as possible. You know, like close everything by default and open only when you need something. By default, etcd console and Zookeeper allows accessing all kind of nodes and all kind of keys, and you can read and write and remove them. If your DCS support role-based access, maybe it's also better to employ it.
So
I hope it answers the question.
yeah. So the as summarized, we have to also implement HA kind of like mechanism of DCS, right? Because we have also
it's not HA mechanism.
not HA mechanism.
DCS already HA on its own because they provide the guarantee that like if you do a write, it will be written to majority of nodes, and like it will survive if some of them will die. But when you still have majority, so like it's already HA.
Already HA, right? Another question from Zoom from Pak F Budiman. Hi Alexander, I found some issues regarding the integration between Postgres and Patroni, which specifically pointing on misconfiguration standby, where Patroni cannot detect misconfigs of standby such on misconfigs recovery settings. Perhaps he has some misconfiguration, but it cannot be detected by Patroni. Is there some features that can avoid this matter, or is it just the nature of Patroni? Please elaborate.
Oh, it would be nice to understand like which exactly issues like they were hit, because in general Patroni is trying to manage standby in a way that it protects people from making an error. Like what may happen, but for instance, what may happen, like you put into Patroni configuration file wrong password for replication or wrong password for super user, and it will break some things down. I don't think we can do much better than that, because it's a configuration management problem, not Patroni. Like we don't want to keep some important values like passwords in the DCS, or like you don't want to keep some certificates in DCS because of apparent reasons. Like by default, DCS is unprotected, and like if you get access to, like you immediately get passwords, or you may do something bad, and that's why like password distribution, certificate distribution between nodes is offloaded to the end user, and we again like better if they give some real details of the problems they face. Otherwise, I don't know how to answer. Like I can only think about like what may have went wrong, but without knowing details, it's hard to elaborate.
Okay, perhaps what he's facing is about when he tries to configure the Patroni configuration on standby server. Even if there is some mistakes or typos or anything, Patroni standby
like,
cannot detect anything.
Yeah, that's also true. So, like at least we have Patroni configuration check. Like if we start Patroni, there is an option to check Patroni config file. However, it will not catch like all kind of errors, like when some parameters are mistyped, because in general, like you might have quite empty config. In the config, you need to declare like user and password. You need to declare REST API connection strings, and like how this node can be accessed locally, like on which port it should be listening to, and how this node should be can be accessed remotely. Besides that, like we need to configure like how to access DCS. Anything else is optional, and that's why like we don't want to have very strict configuration checks. Also with YAML, that's unfortunate. People sometimes not formatted correctly. Like you may shift it like to the left, and you may you end up in getting totally wrong structure. Like for instance, like if you take this slide as an example, like let's say create replica will be moved to the left, and we will become on the same position as PostgreSQL, and it is still a valid YAML, but wrong Postgres config.
Okay. Okay. Any other questions from audience? Yes, please. Could you please give the mic? Please introduce yourself, from which company, Pak? Yes. From GoPay, Pak. Okay.
Let's say I want to create guest user using Patroni. Where should I store this password? Is it on the local file or should I use external service?
What do you want? Can you repeat again the question?
Guest user.
Maybe you can come closer.
Oh yeah.
so-
Okay. Can you use the mic also? Yeah. PostgreSQL using Patroni.
Uh, like if it's a totally new user, like inside Postgres cluster, like you just connect and do create user, you don't have to store it in Patroni configuration. Like if your question is about like, let's say, creating new user which will be used for replication, it's a bit more challenging task. You have like for existing cluster, you need to create user manually and then update Patroni configuration and restart. Otherwise, you will not pick it up. Yeah, please elaborate more. Like what do you ask?
Password. The password on the primary account info, right? Let's say you want to create a replication, and then he want to use a credential. He want to put the credentials on the primary account info. Is it safe?
Okay. So, like the problem of like what and how to keep passwords where so like usually it's a very strange requirement from security people that don't like keeping passwords in plain text in some configuration files. I totally understand that. Like it's a requirement which comes from some audit companies, but in general, I don't think it makes a lot of sense. Let's say you have a password that is kept encrypted in some file, and you want, like, in order to decrypt it, you need still to provide some passphrase. And this passphrase will be, again, stored in some configuration file. And if attacker gets access to the machine, they get access to this file, they get access to passphrase, and they decrypt the password. So they just one step behind getting the real password. It basically just shifts problem a little bit aside, but does not eliminate the problem at all. In general, rule of thumb, like, in my opinion, it's better. Like if you don't want to use passwords, you make it for Patroni to use client and server certificates. Like those are not passwords. Like from perspective of security, you may fulfill requirement. But again, certificates will be kept unencrypted on the file system. And if attacker get access to certificates, they basically get access to all database. Or even worse, like if an attacker managed to get access to the server, they already get access to the database. They don't even need to have the password because the data is there. Like they can just copy it. No?
Yeah.
So in general, like regarding primary info, what Patroni does, it does not put password in the primary info. It creates a PGPass file, and for primary info, it is referring to PGPass file where password is stored. And PGPass file has very strict access rules. Only the that they allowed to be read. So it's not allowed to be read by group, or it's not allowed to be read by other
Okay.
Yeah.
Because in my opinion, as additional opinion, yeah, suppose we still have to write our password or credentials in files, we can have like to prevent any authorized access, we can implement also to FA. To FA2 for people that, for example, want to have escalated actions, like to open the files or anything, we can implement to FA. Especially, we have products on that. We have Caraka. This Caraka also help you to prevent unauthorized access because it implements also to FA, multi-factor authentication like that. Yeah, that's one of options actually. But we still have to write, yeah, as also said, yeah, we cannot avoid storing passwords or credentials right in files because yes, something yeah. Okay, does that answer your questions? Okay, thank you. Okay, so actually we still have some questions, but we are running out of time. But I think there's still one last questions that quite interesting from Pak Ferdi Saldoni from PT Adireka Mandiri. Good afternoon, Alexander. I had split brain situation where the multiple codes mistakenly become the leaders. Multiple nodes, I think, mistakenly become leaders, and it's resulted to data inconsistency. In the end, we spend lots of time on risk and resources on this situation. Need your advice how to avoid this in the future.
It's nice to understand like how they go through the situation, because that's how out of the blue doesn't happen. To be honest, like it needs to be a bit more
elaborate about how the configuration they implement and so on.
Yeah, it was one of my last slides regarding like how to check like if something goes wrong. It's like very often people just look at the last line of Patroni logs and see, oh, like, there is an error, like, it's a problem. No, it's not. Like most likely it's a side effect of something that happened like a few seconds or maybe even a few minutes earlier. Like general recommendation, like, you need really to collect logs from all Patroni nodes. Not only Patroni logs, but also PostgreSQL. And not latest, but like you need to find the time when problem started to develop, because maybe there was some network, like short network problem. Then it like snowball, grow and grow, and like there will be some evidence in Patroni and Postgres logs. Once you collected all logs, you need to build a timeline how problem started, how it developed, like what happened first, the second, the third, and like how we got to the situation. And only when we understand the entire picture, we can make some decisions to how to protect from such a problem not happening again in the future.
So we have to analyze all the findings in the logs.
It's not a simple task. And it's not enough to look just on a single node to understand what's happening. We need to get a full picture from all nodes.
Okay.
Because they may influence each other. How they make decisions, like what's happening in each order. And maybe actually not only Patroni, Postgres logs, maybe there was something bad happening with ADC or console. They also have logs and they provide some valuable insights for what's happening.
Okay. I hope that also answer your question, Pak Ferdi. Yeah. Okay, so I think that's all from the questions. We still have some questions online, but I think we will answer it in emails or something else, or perhaps in the next event. So thank you for sharing the materials from Mr. Alex, and please give us applause from everyone about this thoughtful materials, thoughtful presentation. I hope it can give you insights, yeah, both audience offline on also online. And if you want still have a questions, you can ask directly to Mr. Alex or on the. Is there any forum for questions?
No, there is actually Patroni Slack channel.
Okay, Patroni Slack channel, right?
Yeah,
Yeah.
prefer if a question go to Slack rather than GitHub.
Okay.
Better to have to use GitHub issues, in my opinion.
GitHub issues, right? Yeah. Easier to track, right? Okay, thank you very much. So after this, I will get back to Neva to have a closing statement or closing. Please, Neva.
Okay, thank you so much, Mr. Alex, for the materials of the discussions today. And oke, sebelum kita akhiri acara pada siang hari ini, kita ada form untuk feedback pada event hari ini. Mungkin dari tim boleh di-share untuk barcode-nya? Ya, jadi untuk rekan-rekan semua mungkin boleh dibantu untuk di-scan, kemudian bisa diisi untuk formnya. Nah, sembari kita menunggu pengisian formnya, mungkin Mr. Alex, maybe could you give us some of closing statement, maybe for today's event?
Julian said that like the Postgres community in Indonesia is very small. Like if I try to estimate the community size based on the amount of questions I got from the audience from the internet, I would say like it's a very big community that very curious focus. It's the way to go, and I hope like you grow even further. Because thank you so much for doing these sessions. I understand it's weekly sessions. Yeah, it's a very valuable contribution to my team. Focus existing, and thanks for inviting me here.
Oke, thank you so much, Mr. Alex. Oke, buat tepuk tangannya rekan-rekan semua untuk